So starting right in, we're going to talk about our uniform distribution. Our uniform distribution is a special type, a subcategory of our continuous probability distributions, right? And this looks something like this. So uniform distribution is going to have the probabilities on the y-axis. It's going to have the values, possible values, on the x-axis. So this is our probability of x. These are our x's. And we're given two values when we're told about the uniform distribution. We're given a value of a, and we're given a value of b. And then because of the fact that this doesn't necessarily start at 1, we go ahead and do a little break right there. Or start at 0, rather. Well, it always starts at 0, but gives us a break so that we can skip some stuff to start between a and b, right? And so the uniform distribution looks something like this. And so the uniform distribution has the same probability for any value within the range of a to b. So uniform probability distribution just looks like a rectangle. And one of the things that we know about our distributions is we know that well, we don't know this yet. So we're going to come back to this. I'm going to give you the formula right now, and then we're going to come back and we're going to define how we got to these formulas because it conceptually helps. So whenever we have a range from A to B and the probability is the same, we know that these are all related to each other. And the reason why they're related to each other is going to make more sense once we talk about the continuous probability, the more general case of the continuous probability distribution, a normal distribution, right? So in this uniform one, though, the probability for each one of these is going to be 1 divided by whatever this value is, the second value, b, minus whatever that first value is. So uniform distribution, it's rectangular in shape. When we are asked for, so the first situation of this is rectangular in shape. Oftentimes we are interested in the central tendencies of these distributions, right? And with this particular one, the median and the mode, mean, are equal. So the median and the mean are equal, and they are going to be halfway in between here at the point of a plus b divided by 2. That's going to give me my mean and my median. So you're being told the minimum and maximum values, and then you can calculate the mean, standard deviation, and any probability of any of those points in there. So you're just given those A, B starting values, and you can do the rest on your own. Questions on that part of the uniform distribution? So we already defined what the mean was, right? The mean, or mu, is just equal to A plus B over 2. The other part that we're constantly defining in these distributions is our variance, right? Our variance for this particular one is equal to a square root of b minus a squared in the top divided by 12 in the denominator. And when we're talking about this whole situation, if we wanted to describe this in an equation, it would look something like this. P of x is equal to 1 over b minus a, and this would be if A is within the bounds that we've been given, the A and B bounds, and then the other part of P of X is that it's equal to 0 elsewhere. So these are the two equations that describe this uniform continuous distribution here, this rectangular distribution that we have. Questions on calculating? Again, we're going to go through the kind of why of it later. Might be in a supplemental video just to save on time, but questions on this in terms of just applying the formulae that we're being given? Okay, cool. Fairly standard. Good stuff.